There are multiple factors to make your website go fast. GCP, AWS, Azure, Cloudflare, those four companies makes the whole internet infrastructure go run. If I list those factors that is responsible to make your website faster, the first would be the content. What are the content you deliver? The second one would be next fast to render. Third, JavaScript or WebAssembly. Fourth, browser engine. By the way, this browser engine you cannot do anything. It depends on the market. Whether your clients or customers are using Gecko, Chakra, V8. I remember Lynx was a thing back then. What are the codecs you use? As Flash is dead, you must use some kind of codecs to deliver your content. The main point nobody talks about is latency. If you see over here, the latency is not mentioned over here. And last, the transfer of information or data. In this digital era, light or electric is the way to transfer data. In future, we may get quantum entanglement in each and every modem, I assume, so that there is no latency between server and the user. But still, that technology is not available for any kind of user. So we will stick to the electronic and light way. That means any information and data goes through your twisted pair of electric wire or you get fiber optics. First, we will discuss about render blocking things, JavaScript, CSS, those simple basic stuffs. If I take an example with this Vercel website, it has no interactivity or heavy animation, anything like that. Still, the score is 68. The score is so low, still you get cumulative layout shift is 0. That means this website was generated by some kind of JavaScript engine. There are multiple proofs that you understand. If you see this CSS, you get source mapping. That is a full proof that it was generated by some kind of JavaScript framework. By the way, Vercel is famous for implementing and inventing new JavaScript technologies. Still, they are having legacy JavaScript. I'm not sure how they can do it on their own website. What about this website? I'm not even willing to mention the website name. Still, it performs 91. This also have cumulative layout shared as 0. That means this website also rendering the HTML, CSS, each and everything using JavaScript. And it is also using some kind of build process. But this do not have legacy JavaScript and other issues. That is the reason why the performance score is much higher. It's like getting 91 on a scoreboard or exam. But it takes 3.2 seconds to paint or render its content. What about blocking time? It around 130 milliseconds, which is quite good. Still not good enough. So I directed someone to take a look and improve the performance. It was getting 100, but I realized they used a lot of tricks just to make the score good. That means it will show as 99 out of 100, but on a real use case, user will not get the benefit having a fast website. Let me give you an example. If you bundle up all the CSS and JavaScript in a single file and deliver using CDN, all of your user will get a much better experience as those files will be cached in their browser. Each and every time your user will ask for a new page. That means only the content will be fetched from the server, rest of the data will be on their browsers itself. Thus, the user will get much better experience. Still, if you use that route, Google will show you many errors. That is because of their calculation error. What I think is they have a very bad taste of calculating things. What I did next, I asked someone else to handle this situation and really make the page speed better on the scoreboard. Along with that, the user also should get a better performance. So now we are getting 100 out of 100. I am even stunned, like the cumulative layout shift is not full 0, but you can say it is 0. Largest content paint is less than half second. There is no blocking time. The fast contentful page within half second and speed index is less than 1 second compared to what we had is 3 seconds. Especially at this point, if you compare with our current ongoing development server, which is having less than half a second. What about mobile? It is also 100 out of 100. You see, on mobile, you are using some kind of ARM-based CPU, and ARM-based CPU is not good for single core performance. That means any browser that use JavaScript can only use on single core. That means in simple terms, one powerful core JavaScript needs. So on mobile devices, it is very hard to get 100 out of 100. Still, this version, that means the next version, it will get 100 out of 100. It is very good to know. What are the other aspect of website? Like if you see, I am having 42 websites that I personally take care of, and I have two monitoring system to monitor all those sites. Let's take an example regarding this one. Do you see those spikes? Sometimes it gets 1 second 400 milliseconds, sometimes it takes only 400 milliseconds. That means there are some kind of server latency, and the server latency is 3 times more. On an average, you get 400 millisecond for the same website. If I see from another Uptime Kuma dashboard, it flattens around 400 milliseconds. Sometimes it gets 2 seconds. It is not about accuracy, like this Uptime Kuma is giving more accurate data. It's about having those Uptime Kuma monitoring system on different continent. I want to see how all those sites performance from various continents. Let's take another example of this site. On an average, it is around 100 to 900 milliseconds, but here you see it took around 2 seconds. For the same site, it shows another report from another continent. It took only 200 milliseconds. Still, it do not cross the 400 millisecond barrier. Do you see the difference? Let me show you much more deeper so that you understand much better. Now we are having like 4 or 5 lookup servers. Those servers are responsible to look up the latency between our various data centers. This one is on Helsinki. See, within Helsinki, it gets the lowest ping as possible. That is under 4 milliseconds. But as you go far away, the latency increases. 25 millisecond Amsterdam. From Amsterdam, if you see, it is 31 millisecond. What about London? From London, it takes around 40 milliseconds. Let's go far. What about Miami? It is around 133 milliseconds. What about Bengaluru? That is our hometown. It is around 150 milliseconds. Let's see it from the another lookup server that is situated in Bengaluru. What about this one? It is 8 milliseconds from the Bangalore itself. And what about Helsinki? It is 165. See the difference. Same Helsinki latency over here is only 4 milliseconds, but from here we get more than 150 milliseconds. So you will have to distribute all of your loads between different continents. That is the only way to make your website go faster for the world. Especially if you are targeting your audience to the whole world, the latency between your server and your user must not be more than 200 milliseconds. See, the issue is if your server and the user latency is 200 milliseconds, the first initial 200 response would be more than 4 to 500 milliseconds. As the user is requesting your server, it takes 200 milliseconds and the server is returning with data that will take minimum of 200 milliseconds. That means the 400 milliseconds latency is a must. If we think or assume your web server takes no time to return any output, as you understand, your server needs at least some time to authenticate the user, to get all those data relevant to the user's query. So there must be some latency. It is around, for our server, it is around 50 to 40 milliseconds. That means if the latency is 200 milliseconds, the response you get from the server is minimum 450 milliseconds. See how the latency is increasing step by step. We are having another example. This is from my home itself. I am not here on Bangalore. I am on a remote place. The city is Habra and the minimum latency is 61 milliseconds from my home Habra to Bangalore. That is the reason why the 61 millisecond is showing over here. What about Singapore? As you see, from my home to Bangalore is 61 millisecond away. That means it is also a way to measure distance. It is not about kilometer or mile. It is about millisecond. How millisecond far are you? From my home, it is 113 milliseconds away, Singapore and Hong Kong or even Tokyo. But Bangalore is 61 milliseconds. The longest one is around 400 milliseconds for Sao Paulo. By the way, I am curious about this city, how far I am from Sao Paulo. Let's do a Google search. As you know, Google is the internet. For some people, Google is the internet. For some people, Facebook is the internet, but I'm not sure what is internet. Okay, let's go to the map itself. I assume it is more than 10,000 kilometers, and still it is only 400 milliseconds away from my home. Quite impressive. 10,000 kilometer in light speed. On an average, light should take only 34 milliseconds to go to Sao Paulo from here. But it should also return. That is around 70 milliseconds in total. But we are getting 400 milliseconds. How come? The additional 300 milliseconds is coming from network infrastructure. I wonder how fast those network infrastructures are. Like, it is taking less than 300 milliseconds to process all those data from this continent to that continent. By the way, I took another VPS from another company and tried to make some sense. What if I had a data center, even on a rented data center in America? Like, I don't use American technology. Even American inventions like gravity don't work over here. That is the main reason why I don't use American technology. So from New York, it is 6 milliseconds. From Denver, it is 45 milliseconds, and the rest of the city even don't get a ping distance. On this digital era, we send data using electronic medium or using fiber optics. What about quantum entanglement? I'm not sure if even this technology is real or not, because I have never seen anyone using those technologies. I've just heard like those type of technologies are exists, and in future we will have those technologies built into our modems. I'm not sure. Okay, let's not get into those theoretical matter. Rather, we stick to our first plan, which is how we make our website faster. Like, whatever the content you are sending, the text, image, animation, audio, video, those type of information you are sending from server to your user, all those HTML, CSS, even JavaScript are sent as a text. That means a simple gzip will be much easier to send those data. That means a 15 KB. As I remember, this next version of the website is using some kind of gzip, and it makes a 15 to 20 KB HTML and CSS into 5 or less KB of CSS. That means you get 3 times of compression, so that it becomes much faster to load on your user's device. Even this scores 100 out of 100. There are other scope of improvements also there. As you see, 580 milliseconds, that means only 8 KB of data. It is showing as red. That means it can be optimized. Another one, it is using Astro, and the terminal window, that means, let me see the page. This terminal window is taking 800 millisecond for 4 KB of data. You understand how optimized this one is. It is having multiple tabs, having some kind of animating things. Still, it is performing 100 out of 100, only consuming 3 KB. But I understand it must not be 3 KB if I unzip or simply save it. What is the file size? Let me see. Here is the file, terminal window.js. It is 12 KB. Say it is 12 KB. But I remember it was showing as 3 KB. Why? Because the server delivered as a zip file. I wonder about those files. It is around 60 KB. Still, Google has no complaint about it. Okay, that means only gzip is the only way to compress text, HTML and CSS. But what about audio, video and animations? Back then you had Flash, the so-called closed source technology, to make animations and videos appear on the website. If I remember correctly, even YouTube did deliver videos using Flash itself. Nowadays, Google do not deliver anything, or any company, no company use Flash technology. Rather, all of us are using either H.264 or H.265. By the way, H.265, that means the HEVC technology, it is not in use by any browser engine. Not even V8 use that by default. Till the date, H.264, that means AVC, is the standard way for the browser to open any kind of video, even audio files. I think AV1 would be the next to become our industry standard, but there is no way Apple's ProRes will be a standard way to deliver audio video for the web. That is because the ProRes, by the way, the name I don't understand why some kind of Pro must be there within their file format even. Anyhow, the ProRes format is highly optimized for the video editing purpose only. That means it will consume a lot of bandwidth to deliver those videos. That is the reason why like nobody use those formats for the web itself. I remember H.264 has less capability in terms of 8K video streaming, but YouTube does have the capability to stream in 8K. I'm not sure how they do this. Still, H.264, that means the HVC is the standard till the date. What about doing animations? There are simple animations can be done using the CSS only, but CSS has some limitations. That is the reason why each and everyone use JavaScript to do any kind of animation or calculating stuff. That means JavaScript is a standard programming language. That is the reason why many of us used to use JavaScript as their main programming for the web. But JavaScript has some limitations, especially the single thread thing and the blocking and non-blocking part of it. That is the reason why WebAssembly was born. Nowadays, a lot of heavy resource consuming applications are also made by using WebAssembly. That is simply called WASM. And I think WASM is the future, especially if you consider the web or front end. It is much faster, it can handle GPU much better, and it can leverage the multi-core CPU architecture much better than JavaScript. And I think WASM will not be contained on web or front end itself. It will have much bigger impact in our day-to-day technological life. Even WASM has the capability to replace Docker, container, and much similar technologies to enclose and encapsulate one single application. We'll discuss the main part of it, like the browser engine. I remember some of my older projects still runs very well on Chakra, but lags on V8 or even Gecko. So you cannot rely on browser engine because it also depended on market and market shares. So what is the takeaway? Your website or your web app must be lightweight. That means it should be under KB, not MB. Nowadays, I see various websites are even much worse. Like they even have 5 MB, 6 MB of a single page. There was a boom in the past, like 5 to 6 years ago. Like each and everyone wanted their website to be a SPA, that means single page application. But I understand SPA is not the future. As you want to make your website faster to render, that is the main mantra you should follow to have a faster website.